we're going to be talking about is green roofing, and this presentation is W.R. Meadows Green Roofing 101, Better Green Roofs from the Ground Up. So the overview of what we're going to talk about today is sort of taking a step back and like, why are we even doing green roofing? Where did it come from? Why are we using it? Is it working? We're going to talk about system types. You have your tray systems built in place. You have a lot of different options for system types. You have just straight up paver systems with no vegetation. And then we're really going to talk about membrane protection, because it doesn't matter at all what you put over your roofing and what you put on your roof. If the roof itself is not protected, if it's not going to last 20, 30, 40 years, don't even mess with doing a green roof, because you're going to end up tearing it off and losing those long-term benefits. Your roof life should be extended double or more with the use of rooftop amenity spaces and vegetated roofing. And I'm going to talk about that in a lot more detail. And that includes the use of vegetated free zones, or they're also called separation zones. You're going to be saying vegetated free zones in your sleep tonight. It's so important. Vegetated free zones around all perimeters, penetrations, and drains. We'll get to that. So we're going to go through the layers of the system. We're going to talk about how to design long-term, durable green roofs, leak-free, thriving, a little bit about what maintenance looks like, what the warranties kind of look like in general, and a little more on, like ASTM standards, test methods, ANSI SPRI, further reading basically, and codes and standards. Okay, so the green roof you're looking at on the left, that's the 5th floor. That's the Multnomah County building in Portland. Absolutely beautiful views. It's about, I think, 13,000 square feet. I want to show you a lot of pictures in this presentation. If you're not familiar, green roofs are everywhere. They're all over North America. They're all over the world, but we just don't see them a lot because they're up on the roof. So if you don't know about them, you're not even going to see them. So we'll look at a lot of pictures. This is another angle of that beautiful roof. The reason why green roof got started in the United States and Canada, it really took off about 20 years ago. And the primary reason is that municipalities were looking to European and Asian countries that were making use of green roofs for stormwater management and for fire breaks and a number of other reasons. So the primary reason why we use this technology to start out with is for stormwater management. Up to 100% of the stormwater that falls on the roof can be retained, reused, evaporate back out into the natural environment without ever reaching the stormwater runoff system. Most green roofs don't hold 100% water. That's more like a blue or purple roof. We're not really talking about that. But they can hold between 30 to 70% of the water that falls on them will slowly percolate and take about a day or two to get down into the stormwater runoff system, okay? So what that does is that slows down those peak loads of stormwater, those first hour or two after the storm, where every surface in the city is flushing water into the stormwater runoff system. And so the stormwater runoff system's infrastructure is built to handle those 1 or 2 hours of peak loads of water. And so you have these huge pipes. They're very expensive. It's a taxpayer burden. They're never enough. Just about every city has issues with flooding, or a lot of cities have combined sewer overflows where basically your city turns into sort of like a medieval wasteland for a while the sewage drains into your waterways and into the city. Green roofs act as a sponge. They absorb the water, most or all of the water that hits them. The plants use it, the soil uses it, a lot of it evaporates back out into the environment, cooling the air, cleaning the air, and a very small amount of it goes down into the stormwater runoff system very slowly, okay? This is why green roofs got started. Excellent stormwater management technology for dense urban areas. But less and less, that is the primary driver. Now, all green roofs manage stormwater one way or another, but what happened over the years is as cities began to mandate green roofing, or green roofing as one option for stormwater management, for example, Washington, D.C., Philadelphia, Chicago, Portland, all over North America, there were mandates or incentives for green roofing. So a lot of the developers did it, okay? A lot of building owners did the green roofing. And what they started to find over the years is that buildings that have rooftop amenity spaces, or even green roofs that nobody even sees, just if they know about that it's up there, those buildings fill faster. If it's a multi-tenant residential or retail space, office space, multi-tenant buildings with green roofs fill faster. They stay full longer. They lease for more per unit in general. This is the feedback we get from the developer community. And they lease for more per unit. And when the whole building sells, it tends to sell for more than comparable buildings that don't have that rooftop amenity space. So now incentives are less necessary because developers, building owners, designers want to make use of this technology. And the reason why people love it is because it's a really beautiful place to be, especially if you're in a dense urban area. You don't have to walk down the street to go to the park. You can go up on your roof. It really enhances the human experience. And the human experience enhancement goes beyond just like a cool place to have a barbecue. Hospitals are one of the fastest growing sectors for doing on structure vegetation because there are real, measurable, researched health benefits when patients can see nature, especially immediately after an operation or a procedure. So patients who can look out a window for 5 minutes after a procedure and see beautiful vegetation or see any greenery that's living, they have fewer post-operative complications, they use less narcotic pain medication, they want to go back to that hospital. Staff retention is also helped by having a beautiful space to look out the windows instead of gravel. Enhancing the human experience is real, measurable, and very important for the use of green roofing. So the other reasons, and this is not really why people are choosing to do green roofing, but it's the side benefits that make you fall in love with them. And I will say anybody who's worked on green roofing for a while, you tend to get sort of like fanatical about them if you've had good experiences because of all of these benefits. They just solve so many issues that seem unsolvable in our urban areas. So one of the greatest benefits we've discovered over the years is that when you completely cover your waterproofing, parapet to parapet, nothing exposed to sunlight, you extend the life of your waterproofing. And depending on what type of system you choose, that can be double or triple or more. The things that age waterproofing and roofing is exposure to sunlight and thermocycling. So it gets hot in the day, the roof expands, whatever roof system type it is, even a cool roof, it gets cool at night and it shrinks a little bit. That pulls away from the flashing, it pulls away at the seams if there's seams, and over time that's how your roof starts to pull apart and break and age. So when you completely cover your roof with a vegetated roof or with a paver system, you're isolating it from the things that cause it to age. And this is why you get these long extended warranties from roofing manufacturers if you get the whole system through them. You can do 20 years, I've seen 30-year warranties. In general, if you have just about any roof system, single ply, you start to patch and repair around 7, 10, 12 years. And by 15 years, it's usually going to be a tear off, if not sooner. And that, of course, depends on different scenarios, different manufacturers. I've seen them go much longer. I've seen them last much shorter. Different types of asphalt-based roofing systems tend to last a little bit longer. But ultimately, by 10 to 15 years, you're either doing some major restoration or you're planning your budget for the tear off or the re-roof. So the benefit really comes in for buildings that own the building for the life cycle of the building, so that after 10, 15, 20 years, not only are you probably not patching and repairing if you get a good system and design it right, which we'll talk about, but you're not having to put that money into the entire new re-roof. And now you can put that 200 grand or whatever for your campus into something else. So this is why campuses, college campuses, municipal buildings, buildings that own the building for the life cycle of the building love rooftop amenity spaces, because the cost of adding a green roof is offset by the cost of having to re-roof and patch and repair. It reduces the urban heat island effect. It reduces the temperature of that building. Rooftops are the hottest part of your city. When sunlight hits a roof, it turns to heat energy, okay? And it gets hotter and hotter. So on a 90-degree day, you can go up on a roof. If it's a gray or dark roof, it could be closer to 180 degrees. It could be 200 degrees. Even a cool roof on a 90-degree day can get over 120 degrees. They're still really, really hot. And cool roofs are cool for about the first year or two. And then you got to get up there with scrub brushes and a huge amount of water and detergents, which negates the whole process and probably will damage your roof. So usually those roofs aren't that cool for very long. But vegetated roofs, when sunlight hits a plant, it turns into photosynthesis. It never turns into heat energy. They don't get hot. So on a 90-degree day, your green roof is going to be about 90, maybe 85, maybe 80 degrees, depending on when you watered it. They're constantly evaporating water. So they also have a cooling effect. This is why we see vegetated roofs now right underneath solar panels. Solar panels work better when they're cooler. And you put them on the hottest part of the city, which is the rooftop, they're not going to work as well. Their efficiency plummets. So vegetated roofs have a huge impact on the building temperature and collectively on the urban heat island effect. It's the only technology we have to actively reverse the urban heat island effect. So that means you're starting to downsize potentially your rooftop HVAC systems. So if you have a dark or gray or dirty reflective roof, cool roof on your building, and you're pulling in 120, 180 degree temperature air that from the rooftop HVAC system, you now have to bring that down to the temperature that's comfortable inside the building. It's a huge amount of energy. But because your rooftop temperatures don't get that hot with vegetated roofing, you can start to downsize those systems. Plus, it adds a huge amount of insulation. There is an R value that fluctuates, so we don't use the plant R value, although the plants and soil do have R values, but we go with that XPS, usually that XPS insulation. That will show you that in a minute, and that has a great R value too. So tightening up your building envelope, cooling the urban heat island effect, and then all the other benefits that come with that. You've got plants on the roof. Now there's a little stopover for the migratory bees that are dying out because they can't get across the cities without dying. And now we have a little stopover for bees and butterflies and things like that. It blocks a lot of sound. So they're great near airports and train stations if you have a school or something that is taking on a lot of noise. And now more and more, we're seeing these huge rooftop farms, you know, these dense urban areas like Brooklyn, like Detroit, Chicago, where you have these huge spans of roofing, especially these old industrial buildings with really strong concrete decks and no food. And you're getting hundreds of miles away your food's coming from. And then you need refrigerated trucks and packaging and refrigerators to store it. And then you have to get to the store. So you grow it right on your roof. You don't need refrigeration, you don't need packaging, you don't need transportation. You just go up there, buy your stuff, and go back to your apartment. So rooftop agriculture is really taking off. So I spent a lot of time on that because I think a lot of this gets overlooked when we talk about rooftop amenity spaces. They are powerful urban healers. They solve so many of the problems that we have in our dense urban areas that seem unsolvable, like the heat island effect and energy use and food deserts. Now we're going to talk a little bit about the different types of green roof systems that you see. We'll go into the layers and all of that good stuff. Two main categories of green roofs, and I would say maybe a third with modular, but extensive green roofs and intensive green roofs, okay? So these are how we sort of separate out the two different types of green roof systems. Extensive green roofs are like what you see on the screen. They're low profile, there's not trees, there's not shrubs. It's measured by the depth of the growth media, which is soil, but it's not really soil. And we're going to talk about that. Growth media is a highly engineered pseudo soil that is intended for rooftop environments. If you put regular topsoil on your green roof, it's going to fail quickly. It's going to blow off. It's going to clog the drains. It's going to get compacted. We don't use topsoil on the roof ever. Even in the rooftop planters, we're using this highly engineered growth media. It's very rocky. You compact it, it locks together like puzzle pieces, and it doesn't blow off the roof, and it allows the right amount of moisture retention while also allowing positive drainage so you don't get a swamp up there. Can't stress enough how important it is to get a good green roof growth media, and don't try to switch it out with anything else. It is one of the more expensive parts of the system because of that. Okay, so 6 inches or less of that growth media soil is extensive. Okay, 6 inches or more is intensive. And you think of that like an intense scene. So it's a park-like setting. You've got trees and shrubs and waterfalls and barbecue pits and things like that. But mostly what we see for stormwater management and also for amenity spaces are these extensive green roofs. They're the lightest weight, the least expensive, the easiest to maintain, and you get all the benefits that I said just before. And that is growth media that is 6 inches or less. So here's an example of that. This is a multi-tenant residential. This is a huge complex in Portland. It's the Marabella Towers. And, you know, they would have had ugly views of all of this rooftop real estate, but they put green roofing in, all different types of stormwater management. You can see some of these apartments, they have individual planters. You can plant your own rooftop amenity spaces. We're seeing this a lot all over the place where with your apartment, you can pay a little extra and get a rooftop planter bed to grow your veggies on the roof. So we see this a lot where we use like pollinator habitat. These are more like stormwater management systems and more environmental, less amenity space, but they can be amenity spaces. Semi-intensive is kind of in between. So maybe you have like a rooftop meadow, and some places it's 4 inches and some places it's 8 inches because it's mimicking the natural environment, or maybe you have a slope on your roof. So we call this semi-intensive. These are more perennials or reseeding annuals, and they're more generally focused towards recreating the natural environment generally for pollinators or to obscure, you know, ugly views on a beautiful residence up on a hillside or something like that for neighborhoods. This is a really pretty one on the coast of California. I think this was in San Jose, and they used native plants. Native plants are hard on green roofs, so make sure you talk to a horticulturist. Usually we're using acclimated plants beneficial plants, but native plants generally need more soil than a green roof. So you want to set your client expectations about straight up native plants, but you can use beneficial acclimated plants that aren't invasive. So that intensive green roof, it's intense. There's trees, there's waterfalls. You don't even know you're on the rooftop usually. And obviously these are going to be maintained like a park-like setting. You need pruning, you need irrigation. You always need irrigation, in my opinion, and according to best practices. Even if you don't use it, you need some irrigation so you don't lose your whole system in a drought. You know, you may not ever use it, or you may want to design a system that doesn't need it. Just for the fire codes, you have to have water access on the roof. So have a hose up there if nothing else, but don't try to do a no irrigation system. But when you get into these intensive systems, you're going to be doing everything on a park-like setting. Plus you have drains, okay, and structural weight considerations and wind resistance concerns. So we see these more on multi-tenant residential buildings. We see these on fancy corporate headquarters. We see these outside of the CEO, the C-suite offices. And we also see these on hospitals, especially in dense urban areas. In fact, that was a hospital, that last one. We see these in dense urban areas. This one on the left here, Oregon Health and Sciences University, they have green roofs all over their campus because they know the benefits of it and they invest in it. And so we see a lot of these tree park-like settings in dense urban areas on hospitals where the patients and the staff can't get out to the street level, or maybe it's dangerous or it's not healthy for them. They're hooked up to machines. So they do it on the rooftop. So remember when I said that the vegetated roof will last double or triple compared to an exposed roof? That's only true if you do it right, okay? Just like with anything. So you need to specify durable roofing. If your project doesn't have the budget for a good, solid, long-term waterproof system, which doesn't have to be crazy expensive, by the way, put the money into something else. Don't try to compromise on the waterproofing and say, oh, we'll have leak detection or something like that. If there's a leak, we can find it. Don't rely on leak detection. Don't rely on a warranty. Get a good, solid waterproofing system that can withstand constant moisture, okay? So we want hydrostatic roofing systems. They can hold water. Most roofing systems are designed to be hydrokinetic. That water has to flow off. They're not meant to hold water. They're meant to shed water. Even the low slope roofing systems, we don't want ponding water on the roof, which means water on the roof more than a couple of days. Even in green roof systems where we're holding a ton of water, it's being held in the drain board and the soil, not on the roof membrane. But drains can get clogged. You don't want to lose your entire investment because you chose a hydrokinetic roofing system and then the drain gets clogged because something like COVID, people can't get up there to maintain it. It turns into a swamp for a couple of years. You need a roofing system that can handle that, okay? And there's all kinds of affordable roofing systems that are good for that. But what we typically see, whatever roof system that you use, you're using an inverted roof membrane assembly. So you're basically covering the entire roof with insulation. Your waterproofing roofing is going against the deck, and then your insulation is going over it, and we're using a waterproof extruded polystyrene XPS insulation. But one of the big keys, though, is that you can't leave any roof exposed, all right? And I'll show you a picture of that, what that looks like. The part that's exposed is going to age faster, and then your whole roof is going to have to be torn off, even if the part under the green roof is covered, all right? You've got to have vegetated free zones, and we're going to build those out, and I'll show you what those are, and you have got to protect your drains. And that's true on any roof. This isn't just green roofing. If your drain gets clogged on your roof, you potentially void your whole warranty, and you can do a lot of damage. And they have to have maintenance, just like any landscape system. You got to pull weeds, got to clear the drains, you may need to water. Taking a step back, I have what I call my unfortunate specialty over the past closer to 20 years now that I've been doing this. And that specialty is somebody will call me and say, I have a green roof, it's leaking or it's dead or both. And so I'll go in and we do forensic investigations and we figure out what went wrong. And so I've seen over and over and over issues on green roofs. Now, I will say the vast majority of green roofs are thriving, they're leak-free, and everybody's very, very happy with their systems. And you can talk to building owners about that. But the ones that go wrong, they go really wrong. And some of the ways they go wrong is, first of all, choosing a substandard waterproofing membrane to save money that's going to fail before the roof even goes over it. But people aren't really doing that so much anymore. But one of the other factors is leaving part of the roof exposed. So this area of single ply that's exposed is going to age way faster than the cool area underneath the vegetation to the left. It's collecting debris right against the membrane. This is all real bad stuff for roofing membranes. So the detail that should have been done here is that gravel or pavers should have filled in that exposed area. And you can see why they did it. There's some sort of mechanical equipment that is some kind of rack that's tying down into the membrane, and they didn't want plants going around that sensitive flashing detail, which is great, but now go back and fill it in with gravel or pavers, because when that area right where that metal edge restraint is against the membrane, that's where you're going to start to get splitting and cracks, because this roof on the left is stable and the roof on the right is moving around as it gets hot in the day and cool at night and that kind of thing. So you don't want to do that. So what we do is we cover those sensitive areas where you have roof tie-ins, where you don't want to be digging through plants and soil. We cover those with gravel and pavers, and that's called a vegetated free zone. And it's absolutely critical to the long-term success of your system. So let's take a quick look at the cross section of green roofing here and what all the layers are. And of course, every system is different. They're pretty much all have their little proprietary details, but ultimately you see the same things. So remember I said we're generally doing inverted membrane assemblies, or we're doing protected membrane assemblies. And that means that your roof is generally right against the roof deck. And usually for these higher structural weight capacity roofing, green roof systems, we're seeing structural concrete decks. And then you fully adhere your waterproofing roofing right to that structural deck, okay? And so, you know, I prefer liquid applied systems. They don't have any seams, but I've seen successful green roofs on just about every type of roofing system. I've also seen failures on just about every type of roofing system. So it really comes down to the quality of the product you select, the installers, and the maintenance. So you fully adhere your waterproofing right to the deck. And we like this because it creates a very stable substrate. If you drop a tool and it goes down through the waterproofing and it hits that concrete, you probably never even know about it. If there's insulation under that waterproofing, like in conventional systems, that water can travel, you know, and go take a vacation 100 yards away before it finds its way into the building. And now you are digging up the roof and chasing down a leak. Electronic leak detection system does not solve this problem in a lot of cases, okay? Leak detection systems can't tell where there are leaks if it's on a vertical detail, only horizontal. And most of your leaks are gonna happen at flashing details, which tend to curve up vertical. So your flashing is anywhere you have a penetration to the roof or a perimeter or a drain. So you have your fully adhered waterproofing membrane, and then you put your insulation over the waterproofing. And this is extruded polystyrene, XPS, not expanded polystyrene, not the cooler beadboard stuff, okay? EPS, no. It will take on water, it can get crushed, it loses its R value over 20, 30, 40 years that it's gonna be on the roof. Extruded XPS polystyrene, very important point. Doesn't take on water. I've seen old roofs that have been down for many, many years, torn off. That stuff is still in excellent condition and it goes on the next roof. Good stuff. Then you have your drainage medium, and this can be that plastic egg crate. I'll show you a bunch of pictures. This is basically what is taking that storm water and holding it while draining a little bit, but allowing a little bit to stay in the system to evaporate back up into the soil for the plants. Then you have some filter fabric, some kind of fabrics there. And then you have your plants and growth media. So that's basically a cross section. And like I said, every company has their own little proprietary way of doing this, but these are the main systems that you're going to be seeing. Most importantly, right against your roof membrane, you want your root barrier. Okay, this is generally high density polyethylene. It's just like a sheet of plastic. It rolls out across the entire roof. Maybe you tape the seams, maybe you overlap them. Buy a lot, check your manufacturer instructions, but everywhere there's roof membrane, the root barrier goes. The root barrier is the only thing that should be in contact with the roof membrane, nothing else. There's an ANSI spray test for, or ANSI spray, what is it, VR1, I'll show you here in a minute, for root barrier, where you can actually get that approval to make sure that your root barrier qualifies. Things like roof coatings, chemical coatings, copper hydroxy, not doing that anymore. That stuff, most municipalities have outlawed those things because they run off into the stormwater and they don't really work. The root barrier is to keep roots from getting into the waterproofing system or into the building envelope. Well, we say, why do we need that on this project? I've got sedum, they're shallow roots, because a weed seed could land and make its way, get a root that goes all the way down and get down into your drainage system or something like that. So we keep the roots out by this very cheap, simple, high density polyethylene layer. Don't put it any place except for on the roof membrane. If you try to put it over your insulation, because intuitively like, oh, let me just stop the roots before they get down into the whole system. It can cause condensation issues. It can cause displacement of your growth media. Don't put it there. There's a whole other presentation I could give on that, but just for this presentation, everywhere there's roof membrane, you're covering it with the high density polyethylene root barrier, usually 20 to 30 mils. Then we have our extruded, not expanded, polystyrene insulation. Okay, so these are resistant to waterproofing. This is great stuff. It lasts forever. If you tear off your green roof in 30, 40 years, hopefully you won't have to, but if you did, you could probably reuse that stuff. It's wonderful. So one thing I didn't mention when we talk about longevity of roofing is landfill issues. There's one more benefit. Roofing is one of the worst offenders in landfills. Think about every single building you pass every day just on the way to the grocery store, and every one of those roofs probably torn off every 10 years, maybe 20 years if they're really, really lucky, and all that whole footprint of the building going into the landfill. And it doesn't break down because it's waterproofing. And it'll be here long past when humans are here. And it's just filling up the landfills. And most of that stuff you can't recycle. So when you put on a vegetated roof, you're doing a great service to landfill and waste issues. Okay, so insulation. Now your insulation and your root barrier are going to go parapet to parapet. You're going to cut out a little hole where there's a drain or if there's any penetrations or whatever, but you want this stuff so tightly in there, and it's just loose laid. It's just abutted together, and it goes all the way, like in this cross-section detail, all the way to the parapet. You'll notice in this cross-section a little gravel area, and we'll show you that more. That's your vegetated free zone around every perimeter, penetration, and drain. On top of your drain board, on top of your insulation, you'll have some sort of drainage composite. There's tons of options to meet your project needs. There's probably 1,000 options, but they all basically have the main function of retaining some water while draining some water, okay? So remember, we don't want ponding water on the roof. We want to design for that because it might happen, but we want water to shed off the roof slowly. We want the water retained in the green roof system, not on the roof membrane. So that's what this does. The drain board, like the one on the left, can hold a lot of water, but when there's more water than maybe what's structurally planned for or what we want for the plants, or maybe just the water to meet that stormwater mandate locally, then you'll see these holes where the water will drain through. Or you can turn that upside down and have it hold less water, okay? The one in the middle there, top, that wire mesh, we usually see those with sedum mats. That's the sedum plant that sort of look like a sod grass, and they'll grow into this wire mesh stuff. The one in the middle bottom there, that one rolls out like a carpet. A lot of these either snap together or come in big rolls. It looks like a carpet padding. That's really good for more sloped systems where you want that to really grip either the root barrier or the roof underneath and stay in place and deliver water equally at the top of the peak and also down at the lower end. It distributes the water better. So if you're looking at a steeper slope system, that stuff is great. And then the one on the right is just, we don't want to hold a whole lot of water. We just want a little bit of water, and the rest of it's going to run off. It's just got little tiny cups, and that's going under a paver system, so it doesn't need to retain a lot of water. It's more just to keep it off the membrane. Usually these things are fully adhered filter fabric on one or both sides. If there's not a fully adhered filter fabric on the product, you'll just probably add another layer of filter fabric. Now, this is where the vegetated free zones come in. They sit on top of the drain board. So your insulation, your drain board, your root barrier, everything goes parapet to parapet. You're just cutting out tightly around drains and penetrations. But around every perimeter, penetration, and drain, you need a vegetated free zone. Now, the vast majority of leaks on any roof system, liquid, built-up, modified bitumen, hot rubber, single ply, it doesn't matter. The vast majority of your leaks will happen eventually around the perimeters and penetrations. That's the flashing details. So that's where you have a transition in the roof. That's where you go from a flat surface to a vertical surface or down into a drain. And you're basically like gluing or welding little pieces of roofing down around that. And that's where the leaks tend to happen, even if it's not for 20 or 30 years. You don't want plants coming right up against those flashing details. You don't want to dig to do maintenance. You need to do visual maintenance, preventative maintenance for roofing. Now, this is true whether you have a vegetated roof or just nothing on it, just an exposed roof. Your roof warranty and your best practices across the board will say you need to do a visual inspection of your flashing details at least once a year, usually more than that, and after storms. This is because where it's most likely to have issues. The National Roofing Contractors Association says at least 85% of the leaks happen in these flashing details. We want them protected. So if you have plants going right up to the edge of your flashing details, and by the way, I'm showing this picture because the gravel in there is that vegetated free zone. If you have plants going up to your flashing detail, you can't see it, you can't do visual access. So right there, if you have any issues, you're probably not going to have your manufacturer warranty cover it or your installer warranty. And also, if there's one little tiny thing, like a little fastener backing out of the counter flashing, you can fix that for free or for $10, right? If you don't notice that because there's plants and soil up against it, it might be a few years and now you have a major leak and you may have a whole tear off and a roof failure. So you really, really need visual access to your flashing details. We don't want plants and soil up against the envelope, okay? We also need water to be able to shed down quickly off of parapets and, other walls extending from that roof. And the gravel allows for that, or you can also use pavers. It's really easy to pull that back if you do have a leak or you just want to check something and make a repair, okay? So vegetated free zones around all perimeters, penetrations, and drains. The one on the left, you can see a drain and then an overflow drain and then vegetated free zone of gravel around all the perimeters. The one on the left was a client I had there. They had 6-year-old roofs that had failed from the day they were installed. And it was because the drains were buried and it turned into a swamp. And they spent years replanting it. And unfortunately, this happens over and over because either the designer, the installer, the maintainer doesn't account for the drains and they get clogged. The roof will turn into a swamp and it'll kill everything. And the same is true on an exposed roof, even if you don't have a green roof on it. That's why we clean our gutters. It's absolutely essential to keep the water flowing off that roof and down into the drains. And I'll show you in a second how we do the drains. Okay, so the roof on the right, every penetration, every soil stack, you have a vegetated free zone of gravel. You can also do it out of pavers. Here's one where we have a rooftop PV system, and you're going to see more and more of these across North America because, like I said, roofs are the hottest part of the city, way hotter than parking lots, way hotter than streets. And then you put your solar panels on the roof. Solar panels plummet efficiency when they get really hot. So like on a 90+ degree day, when you really need that energy for your HVAC system, you're not getting anything out of the solar panels, or you're getting very, very little. So now we're seeing more and more of just put the solar panels right over the vegetated roof. The plants cool the panels function way better, the panels shade the plants, so you get a little more diversity. Some different things grow under the panels than the rest of the roof, but you want to protect every place there's a penetration if you're using a rack mounted system. You can also use ballasted solar panel systems. That's a whole other presentation, all the cool things. But you can see in this picture, they chose to use pavers, rooftop pavers, not ground level pavers, because they'll have the wind resistance, they'll have the structural capacity and all that good stuff, pedestals that go with them for the rooftop, okay? So they chose to go with pavers because of the washing and maintenance of those solar panels, okay? So this is what your vegetated free zone looks like. You go all the way to the edge of your parapet with your insulation, your root barrier, your whatever your drainage composite is. And then on top of your drainage composite, you're going to use a perforated edge restraint. Generally they're metal, okay? These L-shaped metal edge restraints. And you sit it right on top of the drain board. You hold back your growth, and it's just loose laid. It all clips together into one self-contained kind of box or whatever shape. And you loose lay it on top of your drain board. You put a little piece of filter fabric on the soil side of the slots so the soil doesn't go through those perforations. And you hold back the plants and soil, generally 18 to 24 inches, but the rule of thumb is however far your flashing extends, everywhere there's flashing, you're either having gravel or pavers. So you hold back your soil the distance of the flashing so you can make those repairs without having to dig soil. Okay, so you can put the gravel in first and put the L shape under the gravel. Usually we see it the other way. So you can see here, the green stuff that's exposed is filter fabric on top of a drain board. And then that metal edge restraint, loose laid, sits right on top of the drain board, filter fabric, and then backfilled with gravel. Or you can do the growth media first and do the gravel later, whatever your installer wants to do. But basically you're holding everything back so that those vegetated free zones, those flashing details stay pristine. This is the United Nations building in San Francisco, and they had all of these, like a million penetrations up on that roof. And of course, it's not feasible to build a box around every single one. It's just too much labor and materials and metal. So they just pulled the whole, when they came in later and added the solar panels and the vegetation, they just pulled the whole thing back and made one big vegetated free zone. Okay, so, don't get too caught up in a ton of little small vegetated free zones if it's not feasible. The one on the left, this is a beautiful hospital in Washington. I'll show you a picture in a minute what the rest of the green roof looks like, but I just wanted to show you this vegetated free zone. Now they did both gravel and pavers because they have a lot of window washing to do on this roof because there's several floors of a maternity ward, a dialysis lab, and staff offices that overlook this beautiful vegetated roof. What used to be a very ugly gravel heat tank roof is now a beautiful vegetated roof. The one on the right is a client that I had that did not do vegetated free zones. They had grasses take over their roof for other reasons, and they didn't maintain it. And now we have this mess. This is what it looks like. It's a mess. You have constant moisture against your building envelope. Look at all that moss growing on the brick. And I don't know if you can see this, but you have plants growing into the counter flashing. So you go to pull that weed and you're pulling out your flashing. And now you have a major roof repair. It's a mess. Vegetated free zones around all perimeters, penetrations, and drains, what we've learned over the past decades of doing green roofing. Okay, expansion joints, you want a vegetated free zone. Anywhere there's flashing. On this roof, you can see there's a little pathway going out to some mechanical equipment. It'll need maintenance, so they thought they would just go ahead and put a path out to it. The drains there on the left, vegetated free zones around them. Nice, easy paths for window washing. You can use gravel or pavers. Okay, so how do we do the drains? Most important part of the entire roof. If you don't remember anything else I say today, how to treat the drains is critical to the success of your green roof. You should not be patching, repairing, or replanting your green roof for probably your whole career. If you are, something went wrong. We don't design these systems to put in a leak detection to go chase something down. We design them that we don't ever have to use that leak detection system. Okay, again, just like any perimeter or penetration, insulation goes right up to the drain chamber. You see there's a drain chamber around your drain basket. Immediately around it, there must be an airspace. Don't bring the gravel right to the drain basket. It'll get clogged. You'll have to dig. Every time you do maintenance, you're going to have to dig that gravel. It's either not going to happen or it's going to cost a huge amount of extra labor. And you're probably going to do a lot of damage every time. It just doesn't happen. So you need to have that chamber around the drain basket so that every single maintenance visit, you can take the lid off. Look, is there anything in there? No, put it back on. You're done. And then you have your gravel zone or your pavers around it. And again, you're measuring the size of the vegetated free zone, following the size of the flashing if there's no other standard you're trying to meet. Like, for example, the RCABC standard in Vancouver, BC has guidelines on exactly how big those should be, those vegetated free zones. But generally, the rule of thumb is to follow the size of the flashing. But again, perforated metal edge restraint with a little bit of filter fabric on the soil side, holding back plants and soil, and then you have your gravel or pavers, and that very critical drain chamber around that drain basket, okay? Here's one being built out. You can see this one did not have insulation. It was under the deck. So we just have the root barrier on top of the modified bitumen, and then we have the drain board. They did some cleanup, vacuuming up. A lot of the growth media sometimes will blow around while it's going down. You'll have to vacuum it out before you backfill with gravel. And you can see the drain and the overflow drain here. Lots of different ways to do it. You can have a double drain. And the one on the right is a drain. There's a scupper for the overflow, but all drains need a chamber around them and a vegetated free zone, okay? This is different ways to do it. Plastic, metal, round, rectangular, double drains, single drains, scuppers, all of them need a vegetated free zone so you can make sure that water is flowing off the roof. If that drain clogs and it gets backed up, first of all, you void your warranty for waterproofing and plants. Any roof manufacturer will tell you that. You have to keep the drains clear. But you kill the plants and you have a little bit of a swamp up there, and then you have to replant. You probably damage your soil. It's so expensive and unnecessary. So this is a detail that doesn't cost very much and is critical to the long-term success. And I'm going to show you a horror story. The 1% that don't do well go out with a bang, and it hurts the whole industry. I have a presentation through Green Roofs for Healthy Cities on their continuing education on roof failures. And I go into a lot more detail on this roof if you want to see what can go wrong. For some reason, it seems like people don't want me to talk about that, but the architects love to hear about it. Everybody wants to know, like, what can go wrong. So I share it. Just don't get it in your mind that this is what mostly happens, because it's really rare, but it's usually the same exact detail. So just don't do it. But okay, so this is one where you can kind of see a vegetated free zone, right? You can kind of see they put some gravel in there, but there's some issues. There's no chamber around that drain. So they couldn't tell that there was like a thatch layer built up underneath that gravel. And they're not digging up gravel every time they go there to maintain. I probably never looked at that. So this whole roof turned into a swamp. And they just kept adding more soil, more plants to try and bury these weeds that popped up. And it just was a swamp. And the only thing that likes a good swamp is swamp plants and invasive grasses and things that we don't want on the roof. And this one, they put more and more plants. They didn't realize the drain was clogged this whole time. They spent years adding more plants, lots of fertilizer, and the plants would die because it was a swamp. They weren't meant for that. And so we have this fertile swamp where all of the other thing they didn't do is maintain the roof. You got to pull weeds, just like on your ground level. You must pull the weeds always. It's not magic because it's on the roof. You have to do maintenance. So when all the plants died and we have this fertile swamp, this invasive grass moved in, it blew up so fast and let out its billions of seeds, which destroys the soil. You'll never get those seeds out. And then it dies all at once. And now it's a fire hazard. Somebody drops a cigarette on that roof. So lots and lots of problems from swampy roofs from this one little detail, just an inspection chamber on the drain. Okay. I will say green roofs are a fire break. I'm not promoting this, but it's a reason why they're used. So there have been green roofs in this scenario that have lit up and they've gone out really quickly without burning the building down because it's really hard to catch the soil on fire. You've got Class A fire ratings, all of this stuff, but I don't care. I don't want to see it. I don't want to see a fire hazard on the roof. So this is what you want to look out for, and you should never see that, and it's a simple detail to get around it. All right, I already mentioned growth media. So there's different ways. I'm not going to go into too much detail on the makeup, but there's different ways to get it on the roof. You can blow it through a hose. You can use super sacks from a crane that you hold over the roof. And then you bring in your plants. So you can do little cuttings, you can do plugs, you can do tiles. There's tons of ways to do these. You can do potted plants. There's so many scenarios. They all have the same net benefit. It's just a matter of how quickly do you want it to be fully green and what's your budget? There's also these modular tray systems where you get tons of little tiny miniature green roofs and you snap them all or push them all together and put them on the roof. And there's benefits and drawbacks of each. The modular systems are good for people who haven't worked with green roof systems before. They can get their mind around it a little easier. And they're also good for small footprint skyscrapers where you're not going to be wanting to bring tons of stuff up through the freight elevator. Maybe you can't even get a crane up there. And you just need something nice and tidy to take up through the freight elevator. And these pre-planted modules are good for things like that. And you have to do maintenance. Clear the drains, keep the vegetated free zones clear of plants and debris, and pull weeds. That's just about the only maintenance you should ever have to do. Adjust your irrigation if you have it, do visual inspections of the flashing details, call the roofer or whoever is responsible for the roof if you see anything. You probably don't want to get a roof from somebody that's not willing to put a warranty on it. I really like single source, full system warranties. Just about every major manufacturer has some version of this, some better, some worse. It's usually 20 years on the waterproofing, 2 years on the plants. You have to clear the drains. You have to have visual access to the flashing details for it to stay valid. If someone's not willing to put a warranty on their plants, maybe you don't want to put that investment on your roof. Be really, really careful about people selling you things that they're not willing to warrant. Usually it comes in for a single source warranty. If you have 2 different warranties, one for the roof, one for the waterproofing, then they just plan on a whole lot of finger pointing and litigation. And in the end, the building owner is going to end up paying for it. So if you have a single source warranty, they call that one throat to choke, and you can only go to one person and the whole system is their responsibility. So I really like those single source warranties. I'm a big fan. If you want further reading, ASTM E2777 is the guide for roof membranes for vegetated roof systems, and it has tons of different test methods for everything: the soil, the plant selection, the root barrier. ANSI Spry has all kinds of good stuff for fire resistance, wind uplift, for vegetated roofing specifically. Greenroofs.org, Green Roofs for Healthy Cities, more than you ever wanted to know about green roofing. And they have accreditation programs and classes you can take. The FLL guidelines are what we reference generally for soil. And then for the growth media on the roof, how to design that and then make local adjustments. Your green roof supplier will handle all that. You don't need to go and get a whole education in soil science and horticulture. Your green roof supplier will get you the right stuff for your design intent. Factory Mutual 1-35. It has some stuff about green roof systems. I have some objections in there. I think it's a little bit over-engineered and they leave out wood decks and all kinds of stuff. So anyway, it's a reference. And then greenroofs.com is so cool. This is a global database. You can look up any green roof. There's thousands upon thousands of green roofs all over the world with amazing things, amazing amenity spaces and farms and these gorgeous, you just have to go see it. So go to greenroofs.com. You can look up any manufacturer. You can look up different systems. You can look up different cities and see some really cool things happening with green roofs, especially with skyscrapers. Okay, you guys, I just talked really fast. I went through a lot of stuff really fast. Thank you so much for your time.